Hello everyone, today we'll talk about the solution to the problem, strange printer. Feel free to pause the video and read the statement and we'll talk about the solution and some digressions. Because this problem is actually quite a tricky problem in my opinion. To begin with, we can notice that this problem will probably be solved using dynamic programming, using DP. We have the first string at the beginning and we can either split that string into parts, do something in both parts and that'll generate our string. Or maybe we'll paint some portion of the string, and in that case we might have something left at the beginning, something left at the end, maybe some smaller substrings within what we've painted that we have to paint over. But it seems natural that if we have the solutions for every possible shorter string, the best way of creating every possible shorter string, we might be able to combine them into creating a bigger string. However, the problem is that our DP state in the most naive form would consist of the start and end of our substring, or start and length, but also of the letter that is written on that position. And it's pretty hard to do a naive DP where we just try every possible move, because there are n squared times the size of the alphabet possible moves at every position. So that will probably not lead us to a solution. Okay, so let's now take a detour and think about what some good moves to make on a string are. What are some moves that we'll be happy with? So let's take our string. Then we certainly, for instance, are happy when we have a letter A. By the way, since we are trying to paint over that string, then whenever we have a block of letters that are the same, we can forget all of them except one. So if we have 3 A's in a row, this is exactly the same as if it was a single A in a row, because it never makes sense, or at least it wouldn't help us, to paint over some of those A's but not some other of those A's. So you can imagine now that the letters that are neighboring are different, and our string is compressed in that way. So for sure we like a situation where we have an A here and an A here. We can paint over this block and hit this A and this A at the same time. However, of course, there is also a situation that when we paint over a block, then maybe here is an A, here is an A, here is an A. So there may be some middle A's, such that if we paint over them now, then we might be able to avoid painting over them in the future. So maybe we'll hit multiple A's with a single painting. And it's not clear what the best painting would be, because of course we can, by painting too big of a strip with A's, we can cover up some other letters that were also painted in a similar fashion. They are already okay, and now we have clobbered them. So for instance, we're happy to see those A's, but maybe there are some B's within it, and those B's have been painted over earlier, and now we will destroy those B's that are correct now. So still, it's not very clear what we can do. However, of course, we like when those two ends are the same. And so if we have an arbitrary painting, we are painting with color A, and we have some B and C at the ends, then it really doesn't make any sense to paint over that B and that C. And in particular, we can push the left end forward until we reach an A, we can push the right end backward until we reach an A, and this has exactly the same result. That's because if those elements here are not A's, and those elements here are not A's, and I mean at the end the target string does not have an A, then the only thing that we can do here is either we destroy a correct written letter, which is bad, we don't want to do it. Maybe it's necessary, but it doesn't help us to destroy it in this case. Or it was already bad, but by painting an A over it, it's still bad because it doesn't have to be an A. So we know that there is really no reason to use any move that is not painting a given letter over a segment that's between two occurrences of that letter. So we know that for sure. Another thing that we can come up with, which is quite a bit more tricky, is that we might be able to start our solution by painting over the, for instance, first letter of the string. So in other words, we have a string and we have a letter A here. Then our first move might be to paint from A to somewhere to the right, or maybe only the A. And to convince yourself that it's always not worse than some other optimal solution, you can notice that, of course, we have to paint over that A at some point. And as we've seen here, we have to paint from that A to some other A, or maybe just paint over that A. Of course, if we paint over that A in the optimal solution, then we might as well start with painting that A over, and then forget that this A even existed. And of course, if we paint a larger segment, we might, of course, assume that this segment ends on some other A. Then as a result of painting that segment, everything in the middle becomes an A. So everything that was not an A within it is now painted over with a bad letter. So we have to paint over all the letters that are not A's within that segment later with their correct letters. And so we might push the process, the operation that painted our first A, as the first operation of the whole sequence. Because in that case, we do not for some letters we do not overwrite them with A's, but they are different in that case. And of course, all the operations that were after this operation will still be after that operation, and they will still overwrite the letters that they should overwrite. It's not exactly the full proof, but as it turns out, it indeed works to always start with the operation that paints over the first letter. However, we don't really know how long that operation should be. So that leads us to a DP that we'll just remember for every segment how can we paint it, so how many steps we need to paint it. And we can iterate for our starting position over all the other positions, and if that position has the same letter as the starting position, then we might start by painting that segment with the letter from the starting position, and then generating that segment itself. And when we generate that segment itself, then we can forget about one end of that segment, because it will be painted when the other end of that segment is painted. We should not forget about the other end of the segment, which is quite tricky, because we don't want to make the move that paints that letter at this point. Because, for instance, it might be that we take a bigger segment starting at A, but maybe at the end, for instance, we paint this A with a smaller segment, this A with a smaller segment, and we don't want to commit to that move at the beginning. We know that we can make that move that paints the first A at the beginning, but we want to make sure that we remember, because of course if we paint over that whole segment, then everything here will be painted as an A. And you want to remember that those elements are painted as an A, and the easiest way to remember that is to maintain one end of that segment, either the left or the right, to be equal to that A, so that at some other point, so for instance, if we keep the left end of the segment, then if we see an A here, by seeing the fact that the first and last element of that subsegment here is the same, that we do not have to pay for painting it over. And we already know that we don't have to pay for one of those two A's, and also we don't have to pay for one of those two A's, so at the end we'll pay only for a single A. So that's probably the trickiest part of the solution. So we'll be maintaining, of course, from start to end the cost of painting. The cost is 0 when end is smaller than start. Painting any single letter costs 1. And now we'll be going over the length of our subsegment and the starting position from the left. We, of course, can paint the segment from start to end by just painting the first letter with what is necessary, and then we have all the other letters, and that will cost us a single step more, a single operation more. But we might also look for that middle element that is the same as the starting element. So if it's not the same, we continue. Otherwise, we know that the mid is the same as the start. So it can improve our DP from start to end by taking everything after that middle element. So in this case, if we've seen an A here, then everything that happens here we do not care about. We will not paint over that in the operation that paints our first A. And what we remain is this segment that starts and ends at the same letter. We know that painting over one of those letters will be free, because when we paint some A here, maybe one of those, we can extend it to paint the other one. And we can either consider the first A free, or we can consider the second or the last A free. So it doesn't matter. Here we have start +1 to mid. This is the same thing as we would if we would pass this +1 to be here as -1. So it's the same thing as start to mid minus 1. Because those letters are the same, and it doesn't matter which one we want to get for free. And at the end, of course, we want to start at position 0 and get the largest length, because that includes the whole string. So this is a tricky problem. Those proofs or intuitions were not exactly rigorous. So if you have the time, energy, and inclination, then feel free to come up with a better explanation yourself, or maybe with a better approach yourself, maybe with some better intuitions or proofs why those operations actually work, why it's actually optimal.